Peace be upon you, ninth graders. In this video, we will continue studying about the enzymatic properties. Recall that in the previous video, we ended up with the first enzymatic property, which is enzymes are specific. Each enzyme acts on a specific substrate. Before we move to the next enzymatic property, let's introduce the types of solutions. Solutions can be acidic, like vinegar, lemon juice, and acids in batteries, can be basic, like bleaches, soap, and baking soda, and can be neutral, just like water. But how can we tell whether a solution is acidic, basic, or neutral? We can measure their pH using a pH scale. What's a pH scale? This is a pH scale. It's a scale of numbers from 0 to 14. pH values lower than 7 correspond to acidic solutions. pH values higher than 7 correspond to basic solutions, and pH values equal to 7 correspond to neutral solutions. We will now study the effect of pH on enzymatic activity. Let's give this graph a title. This graph shows the variation of the speed of reaction of pepsin, salivary amylase, and trypsin as a function of pH. But what are pepsin and trypsin? Well, these are enzymes that act on proteins. We will start by analyzing the curve related to the speed of reaction of pepsin. How was the speed of the reaction at pH equal 1? Well, it was negligible. It is null. What happened to the speed of the reaction when the pH became 2? Well, the speed of the reaction increased to the maximum. Now, how did the speed of the reaction vary when the pH increased to 4? The speed of the reaction decreased until it became null again. What does pH equal 2 correspond to? It corresponds to an acidic medium. So, pepsin attains its maximum activity in an acidic medium. The speed of reaction of pepsin was null at pH equal 1. It increases to the maximum at pH equal 2, while it decreases to null at pH equal 4. We conclude that pepsin acts in acidic medium. The optimal pH for pepsin is pH equal 2. Now, I want you to pause the video and try to analyze the curve related to salivary amylase by yourself. How was the speed of the reaction of salivary amylase at pH equal 5? It was negligible. How did the speed vary as the pH increased to 7? This speed increased to the maximum. Now, how did the speed vary as the pH increased to 9? The speed of the reaction decreased to null again. So, the speed of the reaction of salivary amylase was maximum at pH equal 7. What does pH equal 7 correspond to? Yes, it corresponds to a neutral medium. The speed of reaction of salivary amylase was null at pH equal 5. It increases to the maximum at pH equal 7, while it decreases to null at pH equal 9. We conclude that salivary amylase acts in neutral medium. The optimal pH for salivary amylase is 7. Pause the video one more time and try to analyze the curve related to trypsin. How was the speed of the reaction of trypsin at pH equal 7? It was null. How did the speed vary as the pH increased to 8.5? Well, the speed increased until it reached the maximum. Now, how did the speed vary as the pH increased to 10? The speed decreased until it reached null again. So, the speed of the reaction of trypsin was maximum at pH equal 8.5. What does pH equals 8.5 correspond to? Yes, it corresponds to a basic medium. The speed of reaction of trypsin was null at pH equal 7. It increases to the maximum at pH equal 8.5, while it decreases to null at pH equal 10. We conclude that trypsin acts in basic medium. The optimal pH of trypsin is 8.5. As you noticed, the enzymatic activity becomes null when the chemical medium is not suitable. So the second enzymatic property is enzymes act in specific chemical media. Each enzyme acts in a convenient chemical medium or a specific pH. Now let's study the effect of temperature on enzymatic activity. This graph shows the variation of the activity of enzyme in percentage as a function of temperature in degrees Celsius. Indicate the activity of the enzyme at 0 degrees Celsius. It is 0%. How did this activity vary as the temperature increased to 40? Well, it increased to the maximum 100%. Now, how did this activity vary as the temperature increased to 60 degrees Celsius? The activity of the enzyme decreased to 0% again. Let's move to the analysis. The enzymatic activity was 0% at 0 degrees Celsius. It increased to 100% as the temperature increased to 40 degrees Celsius, while it decreased to 0% as the temperature increased to 60 degrees Celsius. As you noticed, the enzymatic activity becomes null when the temperature is not suitable. So the third enzymatic property, enzymes act at a specific temperature. The optimal temperature for the activity of the enzyme ranges between 37 and 40 degrees Celsius. At very low temperature, the enzyme is inactive. It becomes active again if the temperature is optimum, while at very high temperature, the enzyme is denatured. It is destroyed. Even if the temperature is optimum, it will no more function. In order to understand the effect of temperature on the enzymatic activity, let's take a look on the enzyme-substrate complex. Enzymes are biological catalysts. In other words, they speed up the chemical reaction and remain unchanged at the end of the reaction. So the enzyme binds to its substrate at the active site, then it breaks the substrate into the products, releases the products, and then it is ready again to bind to another substrate. That's why enzyme can act in a small amount. So what does the high temperature do to the enzyme? Well, the high temperature changes the shape of the active site. When the temperature exceeds 40 degrees Celsius, the active site shape changes and the enzyme can no longer bind to its substrate. The enzymatic activity is also controlled by one more condition. Compare the time needed by salivary amylase to hydrolyze starch into maltose to that needed by pepsin to hydrolyze proteins into peptides. Salivary amylase requires 15 minutes to hydrolyze starch into maltose, less than pepsin that requires 60 minutes to hydrolyze proteins into peptides. So, did you figure out the fourth enzymatic property? Sure you did. Enzymes require specific time to act properly. Now let's sum it up. Enzymes are biocatalysts. They speed up the chemical reaction, they remain unchanged at the end of the reaction, and they act in small amounts. In order to function properly, enzymes require suitable substrate, suitable pH, suitable time, and suitable temperature. At very low temperature, the enzyme is inactive, and at very high temperature, the enzyme is destroyed. And finally, you will be assigned to memorize paragraph 3, page 3 on the support guide and solve question number 13, page 13 on the support guide. This is all. Hope you enjoyed the lesson. Study well and keep safe.